All right, so let's get started. So unit 1, it's kind of an introduction. That's why we're only spending one class period on it. We're going to be talking about some math that you'll need to know, and this will be a good gauge for whether or not you'll be able to, I guess, understand things in this class, because what we're going to be doing is we're going to be combining the math that you need for chemistry with new concepts. So if you're unfamiliar with the math, it'll be really hard to kind of combine them together, right? So I'm just going to go through a brief overview. Hopefully you guys were able to take a look at this after last class. But in chemistry, we use the metric system. So we're not going to be using pounds and things like that. We're mostly going to be using meters, grams, liters, things like that. So there's different types of measurement, and they all have their own unit of measurement. Now, units of measurement, basically, if you have a number in chem or science in general, you can't just write the number. You have to put a descriptor or a unit of measurement behind it. So that would be things like grams. You could put like milliliters, things like that. Okay. All right. In the metric system, we use prefixes to describe what those numbers mean. And so I'll just do a quick example. The ones that we probably see the most are milli. So milli means 10 to the power of -3. That just means 1 over 1,000. Okay, so it's 1,000th of whatever the metric unit is. So if you have 1 milliliter, that means you have 1/1000th of 1 liter. Okay, that's basically what the prefixes mean. And then you have other things. We're mostly going to be looking at milli, kilo, and centi. So you guys don't need to memorize all of them, but just know that if you have these values, you know how to use them. So that kind of means you need to know how to use exponents very well. So just make sure you're comfortable with those as well. Okay, any questions? So I'm trying to speed through this intro part just so that we can go into the practice problems. Okay, and then one last thing before we go into the practice problems. When you do your calculations, if you started your homework, you might have noticed already when you do division, sometimes you'll get really annoying numbers, right? You'll get like 27.1045987. Please don't write all of this because I don't like it. My TAs who are grading will not like it, and the people grading your AP test will not like it. So if you're comfortable using sig figs already, you guys can do that, but it takes a long time to do sig figs, and AP Chem, the test is kind of unfair because it's a lot of problems in a short amount of time. So a trick that I found that works very well is just put the last 3 non-zero numbers after the decimal, okay? So I have some examples right here. So if your answer is this right here, 16.25011, you can just write 16.250. Okay, just kind of just keep it simple, go through them quickly. If you have 3.14159286, you can just put 3.142. Okay, the weird one might be something like this, 1.00004489. You could put 1.000049. So the last 3 non-zero numbers after the decimal. Okay, and if there's a little bit of leeway in this, if you round it a little bit differently, you're not going to get penalized for that. But just make sure you're not rounding too much. So if it's like 16.25, don't just write 16, because then you will lose points for getting rid of the decimal. All right. Okay, so I know I talked really fast. I was kind of info dump. Let's get into practice problems. These, just to be honest with you guys, these should be very easy problems for you as of this point. And if you're having difficulty with this, you're going to have to do a lot of practice problems just to catch up on the math part of this. So I'm going to give you guys about 2 minutes. I want you guys to use dimensional analysis, which basically just means show your work with the fractions. And I want you guys to solve out 1.1, 1.2, and 1.3, and then we'll go over them in about 3 minutes, okay? You guys can feel free to work together when we're doing this practice problems. It's not like a quiet test or anything like that. Feel free to talk with each other if you need to, but make sure you guys show your work, okay? So I'll give you guys about 3 minutes to do that. Alrighty, guys. So I'm going to start going over this. If you're finishing up and you just want to check your answers, feel free to finish up while I'm talking. But I'm just going over them for the sake of time. Okay. So when we are doing these conversion problems, first thing we want to do is find what is given and figure out what's desired. And after that, we set up our fractions in order to find what we're looking for. So if you look here, our given unit, basically the number we start with is right here, 54.5 meters. And we want to turn it into centimeters. That is what's desired. So what we're going to do is we're going to set up our fractions. We're going to write 54.5 meters. We're going to set up a fraction. Now, when we use a fraction to do dimensional analysis, we always want to cancel out the units that we start with. And so if we have meters right here on the top, we can get rid of meters by putting it on the bottom, right? Because if we have a number on the top and bottom of a fraction, they can cancel out with one another. And so we're going to use this conversion factor right here to make this fraction. So 1 meter is equal to 100 centimeters. And then if we set it up like this, the meters will be able to cancel out. The only unit of measurement we have left is centimeters. And from there, it's a pretty easy calculation. 54.5 times 100 is going to give us 5450 centimeters. So that's going to be your final answer. Any questions on what you should punch into the calculator? So again, it's all about canceling out these units. Okay. All right, let's move on to 1.2. And I know I'm talking really fast, but please, if you have questions, raise your hand and let me know. That way I can go over some specific questions, or if you have any personal ones, I can go over them. Okay. All right, so if we look here, we have our starting unit of 15.2 meters per second, and we want to turn this into kilometers per hour. Now, this one's a little bit weird because here we only had one unit of measurement, but here we have a fraction for our unit of measurement, right? And so what we have to do is we need to start by writing 15.2, but it's going to be meters per second. Okay, so it's basically the same thing as this. You got 15.2 meters on the top of a fraction, and you got seconds on the bottom. Okay, you don't have to notate it like this. You can just notate it like this, but just recognize that the 15.2 is the same as being on top of the fraction, okay? And so if you notice, we need to turn meters, the top from meters into kilometers, and we need to change the bottom from seconds to hours. So we need to change the top and the bottom. Okay, so let's start with our first conversion unit. I'm gonna set up a fraction to get rid of meters. So if I have meters on the top and I want to turn to kilometers, what number should I put on the top right here of this fraction? Yeah, 1. We want to put 1. Sorry, guys, I have bad hearing, really old, so you got to speak louder for me, okay? So we want to put 1 kilometer. And the reason why is because we want to put 1,000 meters on the bottom, and that way the meters can cancel out. Okay? And now, no more meters on top. All we have are kilometers on the top. Okay? Now, we're not done yet because we want to get rid of seconds, and we got to turn it into hours. Okay, so we're going to put seconds on the top, and then we want to put hours on the bottom. Okay. Anyone know how many seconds there are in an hour? That's, so there's, no, you're good. So there's 60 seconds in 1 minute. And so how many minutes are there in an hour? Yeah. No, you're good. Yeah, so you're going to have to do 60 times 60, so 3,600. 36, oh, not that way. You want to do 3,600 seconds in 1 hour. You could have actually done this with 2 fractions if you wanted to. You could have done seconds and minutes, and then minutes to hours. You could do it that way as well, but I like doing 1-step processes, so this works as well. So from here we have a, I guess, 2-step calculation we need to plug into our calculator. So easiest way to think about this is you want to multiply what's on the top and divide what's on the bottom. So we have 15.2 on the top. If you go to the second fraction, we would do times 1, but we can skip the ones because 15.2 times 1 is the same number. And then we're going to divide by the value on the bottom, divide by 1,000. And then we're going to multiply by the value on the top, so 3,600. And then you'll get 54.72. So the answer will be 54.72 kilometers per hour. And that will be our final answer. So a little bit trickier because we got 2 fractions or 2 values that we're changing. But that's how you do. You just set up multiple fractions. Okay. Any questions on that one? Alrighty. Okay, let's go on to the third one. And then after that, we'll go into the next section. We'll skip 1.4. I'll give you the answer, so you can check your answer if you want to do it as a practice problem. But we're going to skip 1.4 in class. Okay, so it says the lung capacity of a blue whale is 5 times 10 to the 3rd liters. And so this is our starting number, and we want to turn this into gallons. Okay, now we can plug this into our equation right away like this. So 5 times 10 to the power of 3 liters. And so if you're comfortable doing calculations with this kind of value, the scientific notation, you can do that. But I think it's a little bit easier to kind of, solve it out so you get a number that makes more sense. So 10 to the power of 3, that means that we have 10 times 10 times 10. We got 100, and then we have 1,000. So 5 times 1,000, 5 times 10 to the power of the 3 is the same thing as 5,000 liters. Okay, so you can convert it if you like, but again, whatever you're comfortable with working with, you can do it that way. So it doesn't matter what you put into your calculation. So we got 5,000. Okay, super easy from here. We have liters and we want to get rid of it. So what number should we put on the bottom of the fraction? Yeah, we want to put liters. So 3.785 liters on the bottom, and that is equal to 1 gallon on the top. Liters will cancel out. And then for our calculation in the calculator, you can just do 5,000 divided by the number on the bottom. Okay, and that should give us 1321.00926 gallons. If you rounded it a little bit differently, that's fine, but that's generally the value that you should be getting. Okay. Alrighty, any questions about those three? Yeah, so just make sure that you're very comfortable with dimensional analysis. If you are having trouble with these questions, it's okay. You can literally go on Google and look up dimensional analysis problems, and they'll give you a bunch of practice problems so that you can kind of develop your skills doing this, okay? All right, I promised to answer it in 1.4, so you can write this down for your reference. But 1.4, and you can check your work, you should get a value of 0.984 inches per hour. So if you want to write that down for future reference, maybe do this as a practice problem. 1.4, you should get 0.984 inches per hour. Okay. All right, so that's basic units of measurement and how to convert. Now, if you notice in 1.2, there are units that are a bit more complicated, right? That come in fractions like this, meters per second or kilometers per hour. Now, those are a little bit different from the traditional ones where you only have one unit of measurement. The one where you have a fraction per unit, those are called derived SI units. And you guys don't need to memorize that term. I'm just giving you the fancy smancy name for it. But some examples that you might be familiar with, meters per second, volume of an object is also a derived unit. And so if you take a look at the derived unit, a lot of times in chem, we will use centimeters cubed, and that is equal to milliliters. Now, I want you guys to memorize that because on the test, sometimes they'll give you the value of volume in centimeters cubed. Sometimes they'll give it to you in milliliters. And so you're kind of expected to know that those are the same things, okay? And centimeters cubed, you could probably figure out is centimeters times centimeters times centimeters. Okay. All right, and then the other important formula that you're not going to get on the AP test, but you should be familiar with is density. Density is equal to mass over volume. Okay, D is equal to M over V. Easy way to remember that. It looks like a heart with a line going through. All right. So I tell my wife all the time, I density you. And then she looks at me like I'm crazy. And it's the same look you guys are giving me now, but easy way to remember it, mass over volume. Okay. Usually it's expressed in grams per milliliter or grams per centimeters cubed. Same thing. Okay, so we're going to do 1.5 together, and then I will have you guys try 1.6 on your own. But let's take a look at 1.5. It says a student carries out a density determination lab to find the density of a small spherical metal pellet. He fills a 100 milliliter graduated cylinder to 50 milliliters and drops the pellet in. So I'm a very bad artist, but I like to draw pictures just because it's easier for me to visualize. So I'm going to draw a graduated cylinder. And it says that this student fills the graduated cylinder to 50 milliliters, okay? And then drops the pellet in. So the pellet is gonna go in. Okay? After the pellet goes in, the water level rises to 51.3 milliliters. So it goes from 50 and it goes to 51.3. Okay. It says that the pellet has a mass of 8.74 grams. So I'm going to write that just so that we have it easy to look at, because reading is difficult for me. There's a lot of text and I want to just have everything on the side. So the mass is 8.74. And then it asks, what is the pellet's density? So we're looking for density. So I'm going to go through the step-by-steps, but if you feel confident solving this out on your own, you can just kind of ignore me for a little bit and try solving it. But this is kind of new, so I'm going to go over step-by-step. So we're looking for density, which means we need to use the density formula. So density formula is mass divided by volume. So M divided by V. So if we are looking for density, that means that we need to have mass and volume, right? Okay, which one of these two values do we already have automatically off the bat? Yeah, we got mass. Good. Mass is 8.74. So we can actually start setting up our equation right away. So density is 8.74 grams divided by whatever the volume is. Now, we don't have the volume in the problem doesn't tell us the volume right away, right? But we do have a way to find volume. Okay. It says that here you started at 50 milliliters, and once you put the pellet in, the volume goes up to 51.3. That means that the pellet has a volume of whatever that difference is. And if we're looking for the difference between the two, we just do 51.3 minus 50. And that's a pretty simple calculation. So 1.3. So the pellet, when you put the pellet in the water level goes up 1.3, which means that the pellet has a volume of 1.3 milliliters. So we can just replace this right here with 1.3 milliliters. Any questions about that process? How we got volume? Okay, so from here, super simple calculation. You just need to do top divided by bottom. So you just punch into your calculator 8.74 divided by 1.3, and that will give you an answer of 6.723. And you always have to write the units of measurement, so grams per milliliter. 6.723 grams per milliliter. Okay, so that's density. And I will give you guys a heads up for your exam. You will have a very hard density problem. So just make sure you're comfortable working with this formula, okay? And this is not provided for you, so you're gonna have to memorize the density formula. So just remember, it's the heart with the line through it. Okay? Any questions? Okay, let's move on to, yeah, what's up? Because it's M over V. Because see, it's a heart. A heart looks like an M on the top and then V. It's a little bit weird. But yeah, if that doesn't work for you, then totally disregard what I just said. Just stick to what you know, yeah. Exactly, yeah. Yeah, just make sure you specify. Sometimes they'll give it to you in like kilograms. And then if you do the calculations, just make sure you put kilograms per milliliter. Whatever unit that you plug in is the unit that you get out. Okay. Good question. Any other questions? Alrighty. Let's do 1.6. Now, this is another formula that you're going to have to know. And it's not really a formula, and I think it's very helpful in real life. It's just how to find percentages of things, right? It's very helpful when you're doing taxes, when you're looking at sales, when you're comparing prices of things. This was very helpful for me when I became an adult and I realized how much I get taxed. And I realized that taxation is theft, but that's beside the point. Anyway, moving on. So just make sure you guys know how to do percentages. Now, the percent formula is very simple and you can memorize it however you like. The way that I like to think of it is whatever you're looking for divided by the total, and then times 100%. That'll tell you what the percentage is, okay? Okay, but if this formula does not make sense to you after I go over it and you have your own way of doing percent, totally fine. You can use your method. There's multiple ways to do this. But percentages are usually about what you're looking at or what you're looking for divided by the total times 100. Okay, so if you take a look at the problem, it says that an aspirin tablet has a mass of 3 grams, but it only contains 3.25 milligrams of acetylsalicylic acid, okay? So again, I'm a bad artist, but I'm gonna draw a picture because it helps me think about things. So you got an aspirin tablet, just a circle, and it weighs it has a mass of 3 grams. And this is my aspirin. Okay, so the entire tablet, the total tablet weighs 3 grams. Okay, but the problem tells us that inside of that tablet, you have 325 milligrams of acetylsalicylic acid. That's called the active ingredient. So when you guys take, a Tylenol or an Advil, the whole thing is not the chemical that helps you feel however you want to feel better and have pain relief. Only a part of that pill contains the chemical that you need. Same thing here. The acetylsalicylic acid is only 325 milligrams out of the entire pill, okay? And then the question asks, what is the percent by mass of the acetylsalicylic acid? So this is what we are looking for. Okay, we're looking for the percentage of that, okay? Okay, so we are looking for this compound right here, okay? And so we're gonna use the percentage formula. So what's the number that we have for this chemical? Yeah, we got 325 milligrams. So we're gonna put that on top of the fraction because that's what we're looking for. And then we're gonna divide it by the total. What's the total mass of whatever we're looking for? Yeah, 3 grams. Okay, so we're going to put that on the bottom, and then we multiply it by 100%. Okay, however, you can't just plug this into the calculator. Anyone want to take a shot at why? Yeah. The units of measurement, yeah, exactly. When you are calculating things together, you have to make sure that they're the same unit of measurement. And this might come to bite you in the butt as we go further into the course. Later on, there's a lot more complicated units of measurement, but you got to make sure they're all the same. So what you have to do is make sure that the top and bottom are the same unit. So you could turn everything into milligrams, or you could turn everything into grams. Doesn't matter as long as they are the same, okay? So I'm going to give you guys about a minute, and I want you guys to make these equivalent. Turn everything into milligrams or turn everything into grams, and then see if you guys can calculate what the final percentage will be, okay? So I'll give you guys a minute to do that. If you finish early, just check with the person next to you. But yeah, make sure you convert everything before you find the final answer. So I'll give you a minute. Okay, so again, you could have turned everything into milligrams. You could have turned everything into grams. Does not matter. I am personally going to turn it into grams just because it's less writing for me. But this is going to be 0.325 grams. If you turned everything into milligrams, you would just turn this into 3,000 on the bottom, and that's going to be the same. So either way, your calculation will come out exactly the same. Now, the reason why I add this percent right here, so don't press percent on the calculator, okay? So not on the calculator, but we use this as a unit of measurement. Because if you notice, remember if you have something on the top and bottom of a fraction, what do you do with those? What happens? Yeah, you simplify, they basically disappear, right? So if these disappear, then you have no unit of measurement, right? So your final number is going to come out to be 10.833. But if you notice, this has no unit of measurement, right? And that's why we add the percent. We add the percentage so that we know at the very end, hey, I'm looking for a percent, so I got to have a percent sign at the end. Okay, so just keep that in mind. If this is kind of complicated for you, just make sure you put the percent sign at the very end, okay? But that's the reason I put percentage at the end. All right, any questions about 1.6? Okay, so I want to highlight 1.7 because this is going to be on your exam. It's also in your homework. So if you guys want to make a note of that, like make sure you know how to do 1.7. Make sure you know it. I'm not going to go over it now. If we have time at the very end, I will go over this problem because this problem is stupid hard. And so just make a note of that. But if we have time at the very end, I'll go over it. But I want to get through the rest of the content first. But just make a note of 1.7. Okay. How many of you guys have started your homework problems? Oh, cool. Have you guys gotten to the end? Okay, yeah. This is, I think, the last problem. So be ready for a fun surprise. Okay, moving on. So intro to matter. Hopefully, you guys were able to read this in your reading, but chemistry is study of matter and how it changes. It's made out of atoms and molecules. Easiest way to think about it is atoms are the individual Lego pieces, and then molecules are what happens when you put the Legos together, okay? So if you make a Lego car, that's the molecule, but the red blocks and the blue blocks and the yellow blocks and the green blocks, those are the individual atoms, okay? Okay, periodic table stuff. Hopefully, you're familiar with working with this, but the big letter in the middle is the symbol. The atomic number is on the very top, and the atomic number on the top is going to tell you the number of protons. So if you know the number of protons in an element, that's what tells you the identity. It's kind of like the ID number. Okay, and on the very bottom is the molar mass. Okay, molar mass is basically how much 1 mole of that element weighs. We'll talk more about that in the next unit, but just keep that in mind. It's just the mass of 1 mole of that compound. Okay. Okay, horizontal one, the rows on the periodic table. So when we got the periodic table, the rows, these are called periods as they go side to side. And then up and down, these are called groups. We're going to talk more about why those are important because they have relationships going across and down. But just keep in mind that if somebody says period, referring to the periodic table, is talking about the rows, and then groups go up and down. Okay. And I'm going through this quickly because the expectation is to read the text, which all AP students read the textbook, right? You read all the text, right? Okay, never mind. I guess you guys don't. But anyway, okay, so there are 3 classifications on the periodic table. Metals, nonmetals, and metalloids. They all have their own special properties that go with it. I'm not going to go over them at all right now, but just read about it in the text. So, but this is how they're divided. Now, if you guys notice the pattern, where are all the metals located? Yeah, like the left, middle, and bottom, right? It kind of takes up that big segment. Where are all the non-metals located? Yeah, on the right side, except hydrogen is the weird one right here. And then metalloids, there's like a little staircase function, like figure right here, and that's the metalloids. You guys don't need to memorize like in order what are the metals and non-metals. Just know generally where they are. Okay. Left side and bottom are metals. That's for you, this side. And then right side is going to be the non-metals. And metalloids are kind of in the middle, okay? All right. Law of constant composition, and this is going to be a calculation. So element composition of a compound is always the same. So basically, if you have a molecule, no matter how much of that molecule you have, the ratio or the percentage of what it's made out of is always going to stay the same. So let's go over 1.8 and I'll go over what that means. So if a compound contains 50 grams of iron and 100 grams of oxygen, but then another sample of the same compound, so we're talking about the same molecule. If it has 7 grams of iron, it's going to have the same ratio as oxygen. So what you want to do is set up a ratio calculation like this. So 50 grams and 100 grams on the same fraction. You guys see that right here? And then the other sample contains 7 grams of iron, and you're looking for the grams of oxygen right here. Okay? So what I want you guys to do right now is to use this ratio to figure out how many grams of oxygen sample number 2 contains. Okay, this is a pretty basic calculation. And again, this is something you should be comfortable with doing, solving for variables in fractions. So I'll give you guys a minute to try that out. You can check with the person next to you. have a little bit of time left over, you can try 1.9, but we will go over that next. And I think we'll have enough time to go over that homework problem. So take a minute, try figuring out 1.8, and if you have a little bit of time, start 1.9. Okay. Alrighty, guys. So I'm gonna start going over it. So you should set up a fraction that looks like this. Now there are multiple ways to solve this. I'll show you 2 different ways, but whatever you're comfortable with, as long as the math checks out, you're good to go. Okay. So if you look on the left side, it's 50 divided by 100. You could end up getting 0.5 on the left side, and that's going to be 7 divided by x. To solve for x, you just move x to the left side by multiplying it. So 0.5x equals 7. And then you can solve for x by doing 7 divided by 0.5. And that will give you an answer of 14. Okay, so the final answer is 14. You can do it this way, or you can do cross multiplication. I know some people like doing that, so you can cross multiply. So you can do 50x equals 700. It doesn't really matter. You're still going to get 14. Okay, so the point is you can solve these math problems however you like, as long as the math checks out. Whatever strategy works for you, it's totally cool with me. Okay. Any questions about that one? Okay, this is the last one that we are going to go over before other than the other one, and then we'll go back to 1.7, okay? Okay, 1.9, it tells us that a compound contains 70 grams of copper and 190 grams of sulfur. So it's asking us what is the mass percentage of copper and sulfur. So here you have 2 questions in one for this one, okay? Now, you see the word mass percent, and so we're going to be using that percentage formula, right? So the percentage formula we said earlier is whatever you're looking for divided by the total and then times 100%. Okay, so let's start off by doing copper. I'll do copper in blue. Okay, so you're looking for copper. How many grams of copper do we have? Yeah, we got 70 grams of copper divided by the total. So what's the total mass? Yeah, 260. You just need to do 70 plus 190, right? So 70 plus 190 is 260. Because that's the total mass of the compound, right? If you want to find out the total mass of something and you got 2 parts, you add them together. And then you're going to do 100%. Okay? And for the mass percentage of copper, you get 76 or 26.923% copper. Okay. Any questions about that one? Okay. All right, let's move on to sulfur. Now, sulfur, you can do the exact same thing, right? You can plug in 190 on the top divided by 260 on the bottom. But there's also another way you can do it. If you take a look at this compound, it's only made out of 2 things, right? The total, if you have the whole thing, that's always 100%, right? So an easy way you can do it is just do 100% minus 26.923. If you just get rid of the other thing in there, you're going to be able to get what's left over. So you'll end up with 73.077% sulfur. So again, doesn't really matter how you do it. As long as your math adds up at the very end, you're good to go. Okay. Too much math, huh, guys? That's stressful. Okay, the last section is about alloys. There is one practice problem I put on the very bottom, but I'm not going to go over that one, but I'll give you the answer. If you guys want to figure out why that's the answer, you can. But the answer to 1.10 is D. If you guys want to write that down. 1.10, the answer is D as in density. Okay. Yes. Maybe. Guys, this is an unfair course. We don't know what's on the AP test. It's like there's always problems that people haven't seen before. There's a bunch of nerds that think of these problems and then put it on the test. Okay. So yeah, just make sure you guys read up on alloys. It's going to be in your reading. Okay. You guys ready to go to 1.7? The stupid hard test homework question? Okay. Let us go to 1.7. All right. So I'm actually going to give you guys 5 minutes to work with the person next to you and try solving this out. Just do the best you can. If you can get it, you're more Asian than me, because that's pretty impressive if you could solve this math out. But yeah, try 5 minutes, work it out, see if you can get it. But after that, I'm gonna start going over it on the board. Okay. Alrighty, guys. So I'm gonna start going over it because there's a lot of parts to this problem, and I want to make sure you guys are able to ask questions if you guys need to. But if you guys think you guys are on the right track, feel free to just kind of zone me out and get in the groove and do it your way. As long as we get the same answer, it's all good. Okay, but this is how I solve this problem. Okay, so this problem is difficult because it is synthetic, which means that you have to synthesize or combine a lot of different equations, a lot of different concepts into one calculation, okay? So let's go through the problem. I like to just list out all the values so that I never need to read it again, because reading is not my forte. English my second language, so I think the numbers make more sense. But necklace has a mass of 9.85 grams. So I'm going to write that down. So the mass of the necklace, so I'm going to write neck, is equal to 9.85 grams. Okay, so I can cross that out because I already used it. Okay, the volume is 0.675 centimeters cubed. So the volume of the necklace is going to equal 0.675 centimeters cubed. So I use that value. The necklace contains both gold and silver. Now I'm going to use the chemical symbol from the periodic table. If you want to use G or S, that's totally fine. I just like using these because I'm comfortable using the periodic table, but you guys are still kind of getting in the groove of it. So if you wrote gold, wrote silver, that's totally fine. Okay. Gold has a density of 19.3 grams per centimeters cubed. So I'm going to write that down. So the density of AU, which is gold, is 19.3 grams per centimeters cubed. Okay. And the density of silver is 10.5 grams per centimeters cubed. So the density of AG is 10.5 grams per centimeters cubed. It's asking us to find the percent by mass of gold. Okay, so we're looking for the percent mass. Oh, I want to do it in the right color. Percent mass, but specifically for the gold. Okay, so percent mass of AU, and that is what we are looking for. Okay, assuming that the total volume of the necklace is the sum, so when you add them together, add the volume of the gold and the silver, that's going to give you the total volume. So the volume of the necklace, the total necklace, is equal to the volume of the gold plus the volume of the silver, and that should be everything in there. Okay, I know that was a lot of stuff in one word problem. Do you guys have any questions? Okay. Make sense how we derived everything from there? Okay. I'm going to cover up the word problem now, just so we have a little bit of space to work. But hopefully you have it pulled up on Canvas. That way you can, refer back to the problem, refer back to what I was talking about. But let's start going over it. Okay, so this is a very irritating problem because you have just so much stuff going on, right? You got mass, volume, density, and percent. Okay, so we always want to keep our eye on the prize. We want to look at what we are looking for at the very end. And we're looking for the mass percent of gold, right? So remember from our percentage formula, right? The percentage is always what you're looking for divided by the total times 100%. Okay? So if we take a list, or if we take a look at the list of all of this, is there anything that we can plug into this fraction just right off the bat? Yeah. Yeah, that's going to be the total volume, right? But if you look at the problem, it's not asking for the total or the percent volume. You're looking for the percent mass, right? So instead of this, we're going to be able to plug this in for the total right here. So we can replace the bottom with the mass. Okay, so yeah, this is another irritating part about this problem is that you got total mass and total volume, right? And so it's like, dude, like, what am I looking for? You got to make sure you're very clear about that. Okay, but yes, you're able to plug in the total mass. So you got to plug in now what you're looking for. And so if you're looking for the mass percent of gold, that means you need to plug into the top of the fraction. You need to find the mass of gold. And that's kind of the key that's going to tell us what we are looking for. Okay, so we want to figure out what is the mass of gold. You got this necklace. It's made of gold and silver. You don't know the percentages or the ratio, how much gold, how much silver, but you got to somehow figure out how much gold is in there. Okay. Any questions? Okay. So this is actually a method that people used to use to figure out if people were trying to scam them. Like if I was trying to sell you like a, I don't know, like a gold ring or something, but you know, I was smart and I try to hide like other metals in there. You would be able to use this method we're talking about now to figure out, is the ring actually pure gold, or is there other like junk in there just to make it look like it's pure gold? So this is a method that was actually pretty useful back in the day. We don't really use it so much anymore, but calculations are still the same. Okay, so mass of gold. So if we take a look at all of this, it's not very helpful, right? Because we don't have any formula that tells us the mass of gold or anything like that. However, we do have the density of gold. That's the closest that we can get, right? So we know that the density of gold is equal to 19.3 grams per centimeters cubed. Now, we also know that density is equal to mass divided by volume, right? So if we have the density, we can somehow find a way to find the mass of gold using this density formula. If we do some calculations, we can find the mass of gold with this formula. Okay. Okay, so we don't have much to go on, but we know for sure that the total volume of the necklace is equal to the volume of the gold and the volume of the silver. Okay, so this is what we're going to start with because this is the only real information that we have about the necklace. So if you look at the density formula, I'll put it right here. Density is equal to mass over volume. We want to plug it into this formula right here. Does anyone have an idea of how we can use this to convert it to something we could plug in here? Yeah. Yeah, exactly. We can rearrange this and then plug it in for volume. So if you take a look at this, volume is right here on the bottom, right? But you can rearrange this formula. If you multiply both sides by volume, volume cancels out. We get VD is equal to M. And then you can move density to the other side by dividing. These cancel out. And then we know that volume is equal to mass divided by density. Okay. And then now we have something that we can plug in right here. So when you guys get these units of measurement, when you get these formulas, just know that you have the liberty to rearrange them however you want. As long as the math stays consistent, you can rearrange them. Okay. So volume is equal to mass divided by density. So the total volume of the necklace, we have this number right here, right? We got 0.675 centimeters cubed. So 0.675 centimeters cubed, that's the total volume, is equal to the volume of AU of gold. But we know that volume is equal to the mass divided by density. So we can say that this is the mass of gold divided by the density of gold. Plus, and the same thing here, mass divided by density. We can replace this with mass of silver divided by the density of silver. Okay, so what we did was we took one equation, rearranged it so that we can plug it into another equation. Have I confused you guys yet? No, you guys all right? It's just a lot of work, right? It's just a lot of different steps. So I'm gonna erase this just so you guys can keep track of what we have been doing. But basically, we took this equation right here that we started with. The volume of the necklace is equal to the volume of the gold plus the volume of the silver. And what we did was we rearranged it, or we replaced these with this. Now, if you take a look at this equation, what were we looking for again? Yeah, we're looking for the percent mass of gold, but we have the total mass. What do we need to still plug into this equation? Yeah, mass of gold. Do you guys see mass of gold in this equation? Yes, it's right here. So we are looking for this. We want to isolate this baby right here. Okay. And this is where we need to do all these different algebra shenanigans to get that, because it's complicated, because we got fractions with different denominators. Okay. Okay, so let's do our best to figure this out. So what we want to do now is we want to isolate the mass of gold. Okay, the problem is we got two fractions and they have two different denominators. Now, we already have these values right here. We have the density of gold. What's the density of gold? Yeah, 19.3. So we can actually replace this right here with 19.3. Okay, what's the density of silver? Yeah, 10.5. So we can replace this with 10.5. Okay, perfect. We got rid of most of the variables now. The only thing that we have left is the mass of silver. We don't have a number for that. And so what we have to do is we need to actually come up with our own equation. Okay, because nothing here is really going to be able to help us. So let's take a look at the mass of the necklace. So it says that the mass of the necklace is 9.85 grams, right? The necklace is only made of gold and silver. So it's reasonable for us to think that the mass of gold plus the mass of silver is going to equal 9.85, right? Same thing that we did earlier. If it's only made out of two things, if you find the mass of one, you can find the mass of the other. You add them together, you get 9.85. And so what we're going to do now is, since we're looking for the mass of gold, we want to replace mass of silver with mass of gold, right? That way we're only working with one variable, because you can't solve a two-variable algebra problem. So we got to replace this with mass of gold. So we can rearrange this equation right here into 9.85 minus mass of gold is equal to the mass of silver. And the mass of silver right here, we can replace this with 9.85 minus mass of gold. And there we go. We have a one variable equation. Isn't this fun, guys? Isn't this math fun? Got to come up with your own equations now. Okay. So from here, this is a bit more manageable. It's still a lot to keep track of, just because it's fractions still. Okay. And so, but what we're going to do now is we're going to solve for this. Now, what I'm going to do is I'm actually going to replace mass of AU with X, just so that it's kind of easier to write out as we're solving the problem. Okay. But just remember that X is equal to the mass of gold. Okay. That way we can, when we're solving and we're doing multi-step showing our work, we don't have to write mass of gold. It's easier to write one letter than three letters, right? Okay, let's solve for X. Now, the left side we can kind of leave alone for right now, because the ugly part is on the right side. So what we're going to do on the right side is we're going to have to combine these two fractions. Okay, anyone know how we can combine these two fractions? I want to take a shot. Yes. Perfect, yeah. You want to multiply the whole equation with the denominators of the fractions. So what we can do is this fraction, we want to make sure they both have the same denominator, right? That way we can add them together, which means we need to use the denominator from the opposite fraction in order to get with the opposite fraction. So This fraction right here, you want to multiply this whole thing by 10.5. So 10.5x divided by 19.3 times 10.5. And we're doing this so that both fractions have the same denominator. And on this fraction right here, we want to multiply it by the denominator here. So 19.3. So 19.3 times 9.85 minus x. And so we're just multiplying the whole thing by 19.3. Okay, so this guy, you multiply it by 10.5. This guy, you multiply it by 19.3. And this is what you get. Okay, now, since they have the same denominator now, you can combine them. So the entire denominator is going to be 19.3 times 10.5. You can solve it out if you want. And then we got 10.5x plus 19.3 times 9.85 minus x. And then we can start simplifying things down from here. Okay, so let's do the numerator first. We got 10.5x, which I'll do a different color so it's a little bit easier to see. So we got 10.5x, but we need to take care of this side right here. What we're going to do is we're going to distribute 19.3 to both of the things inside of the parentheses. That way we can get, so basically simplify it. So what we're going to do is 19.3 times 9.85. That is going to give us 190.105. So 190.105 minus 19.3x. And then this is all going to be divided by whatever this is. The denominator, 19.3 times 10.5. 202.65. So far, so good? You guys following along? Hopefully. Okay, and then the left side is still 0.675. Okay, so from here, this is a much more manageable algebraic equation, right? We just need to solve for x. So what we're going to do is we're going to multiply both sides by 202.65. So if I multiply both sides by 202.65, we get 0.675 times 202.65. And so on the left side, or on this side, the denominator disappears. And on the left side, we're going to get 136.789. Okay. From there, we can subtract the value with no variable next to it. So we can subtract 190.105 from both sides. So we can do 136.789 minus 190.105, and that'll give us negative 53.316. So this left side is going to be negative 53.316, and this can just, yeah, what's up?
Wait, how'd you get rid of
0.675. Which part? On the left side? Yeah, what we did first was we multiplied both sides by the denominator. So 0.675 times 19.3 and then times, yeah, 10.5. So we just multiplied both sides by the denominator. Does that answer your question?
Yes.
Cool. Just making sure. Any other questions? I know it's a lot of steps. The 202.65 disappeared because we subtracted the this value, the 190.105. Oh, it disappeared. But yeah, we just subtracted the 190, and that's how we got it. Let me recalculate. I lost my spot too. So 19.3 times 10.5, that's the 202 you're referring to, right? That's what the denominator was. We multiplied it on both sides to get 136.788 on the left side. And then we subtracted the 190. Right here, 190.105. When you distribute 19.3 times 9.85. Yeah. So if I rewind a little bit, it should have been 136.789. And then we subtract both sides by 190.105. Yeah, I want to make sure you guys are getting the steps. So don't feel bad about asking questions. Any other questions? These are good. It's a lot of calculations. Okay. So let's kind of wrap it up. So 136.789 on the left side minus 190.105. And that's going to give us negative 53.316 on the left side. So negative 53.316 on the left side equals 10.5x minus 19.3x. So far, so good? All right. So on the right side, what we're going to do is we're going to do just 10.5 minus 19.3, and that works because they're both x. So on the right side, we're going to end up with negative 8.8x and then negative 53.316 on the left side. Okay, we know that if we have a negative on the left and right, they can cancel out with each other. And then last but not least, we can finally solve for x. All we need to do is divide 53.316 divided by 8.8, and your final answer, or not your final answer, x is going to be equal to 6.058. And if you remember, x is the mass of gold. So all that work to find out how much gold is in there. And we're still not done because we still need to plug it into the mass percent formula. I know, guys. I told you, AP Chem is, it's not fair that you're expected to know how to do this. I think this was on the AP test 8 or 9 years ago. Yeah, this is an AP Chem problem. Okay. So last but not least, since we have the mass of AU, we can plug it into our percentage formula. So finally, we can plug in 6.058 on the top, and then we can find the mass percent of gold. It's going to be 6.058 divided by 9.85, and then we can multiply that by 100, and that will give us our final answer. And now we're done, 61.503%. There you go. That's going to be our mass of gold. Percent mass. Alrighty, guys. So again, just a heads up, you're going to have this problem on your test. It's also on your homework. Exact one. Or no, I changed it with platinum. So it's a different metal. So similar, same steps, but different numbers. So you're going to need to know how to do all these steps. Okay. And just a heads up, there's the time limit as well on the AP Chem test. On the AP Chem test, you have to do 7 of these FRQs in 105 minutes. So if I scale it down for our test, you'll have 25 minutes to do this problem and 2 others within 25 minutes for the test. So it's not just a concept problem, it's also a time crunch, which is why we say AP Chem is not a fair test or a fair class. So just be aware of that. Yeah. Free response, so basically like a calculation problem. Yeah, free response question. Great question. Yes. There's a multiple choice section, which is 60 problems in 90 minutes. And then there's the free response section, which is these calculation stuff, 7 of them in 105 minutes. So that's the 2 parts of the test. Okay. Any other questions? Stressed yet? Absolutely. Okay, that's my goal. Okay, anyway, I recorded this, so it will be posted on Canvas for you guys. But again, just make sure that you guys are prepping for the exam next Wednesday. Your homework is also due then, but I highly recommend that you try other practice problems at the on the back of your book, because just doing your homework, just to be fair, is not enough practice to do well on the exam. Okay, yeah. Yes, please. Yeah. So just do it on a piece of paper, turn it in. What was that?
Does it matter?
Whatever you need to help you, but I recommend actually I'll pull it up. That's a great question. I recommend specifically the ones in your book. So if you go to your text, right? Let me pull up the PDF. So you know how you have your homework at the very end, right? I recommend trying out the problems that are in the additional exercises section. So if you noticed, it's broken up based on sections, and this is kind of just the chunks, like the information you need. But then remember the synthesis problems where they're combined together. That's going to be in the additional exercises. Doesn't mean you have to do all of them, but just try them out. Try to get familiar with the methodology of solving these problems. To answer your question?
Yes.
Good questions, guys. Yes. Yeah, so I recommend, you can do it in your notebooks, but you're gonna have to turn in a physical copy. So if you want to take a picture, print that out and turn it in, doesn't really matter. I just need a physical copy of it, however you want. Yeah.
Can we submit the notes and?
No, notes are all yours. I only need your homework. Yeah. Yeah. So, I mean, honestly, you don't need to take notes. I'm not gonna get offended or anything. It's more for you guys to have something to refer back to and to practice in class. Great questions, guys. Any other ones? Alrighty, guys. Sorry I ruined your 3-day weekend, but kind of get used to it till May because it's gonna be like this. And just to be honest with you guys, it gets harder than this. This is a relatively average problem. It only gets more difficult from here on out. Okay, so something to look forward to.